Assalamualaikum warahmatullahi wabarakatuh. My name is Nik Nur Azleen binti Nik Len with metric number AE180012. So today I'm going to present my final year project which title Analyzing the Moisture in Transformer Oil using Unclad Plastic Optical Fiber Sensor. So for this presentation, we have introduction, methodology, sample preparation, sensor fabrication, sensor characterization, result, and the conclusion. So for the introduction, the oil immerse transformer is a voltage transformation device that utilizing oil cooling method to reduce the temperature of the transformer. So basically, the transformer is contained of two parts, which is a winding over here and the insulation, which is paper and oil. But for this research, we're going to use an oil immersed transformer. So this is the transformer oil. So basically, insulation is a crucial part because it has the highest possibility that contribute to the transformer failure. So for this case, we're going to use a plastic optical fiber, which is can be simply called as a POF sensor to measure the moisture content of the transformer oil. So the advantages of the optical fiber sensor, why we use this type of sensor, is because it is immune to the electromagnetic interference. It also has stability, repeatability, and durability against the severe environment. And the last one, it has a fast response. So this is the cross section of the segmented POF. In this research, we're going to use uncladding method of the POF to detect the moisture content in the transformer oil. The sensitivity and linearity of the unclad POF moisture sensor is going to measure to classify the performance of the POF sensor. The range of the moisture level that used to test in this research is 200 ppm to 500 ppm. The center of the POF cable is unclad to 1 cm that used as the head of the sensor. So in the methodology, basically we have three major steps, which is the first one is sample preparation, which is we're going to prepare 4 different moisture content in the transformer oil, which is 200 ppm, 300 ppm, 400 ppm, and 500 ppm. So the second step is sensor fabrication. In this step, we are going to fabricate our POF cable to act as a moisture sensor. And the last one is sensor characterization, where we're going to test our fabricated sensor in the sample that we prepared in the first step. So we're going to move for the sample preparation. So basically we use 500 milliliter of transformer oil, and then we add the 0.1 milliliter of the ionized water in the 500 milliliter transformer oil to produce 200 ppm of moisture content. So this is the glass container that we use to put the transformer oil and the deionized water, and then we use this magnetic stirrer to mix our sample. For the second step, which is sensor characterization, so first of all, we use 1 meter of POF, and then we're going to remove the POF jacket 1 centimeter at the middle of the cable, and then we soak the bare region of the POF in the acetone for 10 seconds, and then immediately immerse the bare region of the POF that we soak in the acetone in the deionized water. And the last step is we're going to remove the remaining fiber clad. And for the sensor characterization, as we can see here, this is our light source, and this petri dish is content of the sensor head, and this is the spectrometer, and the last one is our software that we use in this research, which is Ocean View. So first of all, we're going to switch on our light source, and then we're going to test the transformer oil, which contain different level of moisture, and then this Ocean View will generate the output of the output spectrum for each different moisture level. So as we can see here, this is our unclad region of the POF sensor, which is we unclad it to 1 cm. So this is the cladding and this is the core. So for the result, this is the graph for the output spectrum for reference oil, which is we can see here the peak of the spectrum is at 680. So we use this wavelength as the reference wavelength that we're going to use to analyze the data for the four different moisture content in the transformer oil. So as you can see here, this is the graph for the 4 different moisture content in the transformer oil. So using this graph, we get the linearity and the sensitivity of the POF moisture sensor. The linearity is 0.9602 and the sensitivity is 0.0764 per ppm. And this is our RSD percentage. In this research, we for every different moisture content, we run the testing for 3 times, and by using the 3 different output from the 3 different output for each moisture content in the transformer oil, we can calculate the percentage of RSD using this formula. So this is a graph for percentage RSD for 200 ppm, 300 ppm, 400 ppm, and 500 ppm. So for the conclusion, based on the experimental result, the sensitivity of the unclad POF moisture sensor is 76.4 milli per ppm, or we can just write as 0.0764 per ppm, and the linearity is 0.96. So for the future work, we can suggest that by using appropriate equipment, a pipette is used to measure the amount of water that equivalent to 30 ppm of moisture content in the transformer oil, which can be handled by the transformer. The second one is the measurement of the unclad POF can be increased more than 1 cm to measure the sensitivity of the unclad POF moisture sensor. And the last one is the performance of the unclad POF moisture sensor can be improved by using another apparatus other than a petri dish to place the head of the unclad POF moisture sensor to reduce the bending radius.